Hello everyone, today we're going to be talking about empirical formulas. Empirical formulas is basically the most basic way to write something. So if you see we have C12, H24, O12. Okay, so what we're going to do is we're going to find the most simplistic way to write this out, which would be CH2O if you divide all the numbers by 12. So at this point, you can't go into any other decimals. You can't go into any simplistic forms. So that would be the empirical formula for this compound. Now, another way to do this is we're going to go into percent by mass. What that is we're going to sit here and we're going to figure out what is the percentage of carbon in this compound, hydrogen and oxygen. So we can work off the original compound. We can also work off the compound that we have here. How we do this is that we know that in this compound, carbon makes up 12 grams per mole, plus the 2 grams from hydrogen, and plus the 16 grams from oxygen, which would give you a total of 30 grams. Now what we're going to do is for every carbon, we have 12 grams of carbon within this, and we're just going to simply divide it by the 30 grams. And what that's going to give us is approximately, give or take, 40%. And we're going to do the same thing with oxygen now. So we have 2 grams divided by the 30 grams. And we're going to have that one is going to give us 6%. Now if we do the same thing for oxygen, we have 16 grams, and we're going to sit here and we're going to divide it by the 30 grams, and that's going to give us 53%. Okay, so how would this work when it comes down to an actual formula? How would we use this? This would be your percent by mass. Now, if we were given this information, what we can do is we can find the empirical formula and work towards a compound. So right here we know that we have that. Now, how do we find out the empirical formula is a different story. What we're going to do is we're going to grab the 40% and we're going to assume that the ending compound we have is 100 grams. So out of those 100 grams, 40 grams is going to be carbon, 6 grams is going to be hydrogen, and 53 grams is going to be oxygen. Okay, and we're going to use dimensional analysis to figure this out. So for every carbon, for every 12 grams of carbon, we have 1 mole of carbon. We just use that one right there. And for every 1 gram of hydrogen, we have 1 mole of hydrogen. For every 16 grams of oxygen, we have 1 mole of oxygen. Now all we're going to do is we're going to hold this to completion to be able to figure out how many moles of each substance we have within this. So we're going to do this on our calculator. We have the 40 grams of carbon divided by the 12 grams of carbon. We end up with 3.33. And then 6 divided by 1 is going to give us 6. And we have 53 grams of oxygen divided by 16 grams per mole. And we end up with 3.31. Okay, then out of all of these numbers, we're going to choose the lowest number. And the reason why is because we're going to simplify this as far as we can. The same thing we would do trying to find out the empirical formula. So we're going to divide everything by 3.31. This one would equal 1. This one would get extremely close, so relatively 1. And this one, on the other hand, would be relatively 2. Extremely close numbers within a 5% error. So our ending answer is going to be 1 carbon, 2 hydrogens, and 1 oxygen. So our empirical formula after this is going to be CH2O. Now if we were to tell you that the molecular compound, the one that we actually got this information from, weighs 180 grams per mole, the only way we'd be able to find this out is to find the molecular mass of our empirical formula. So we're going to work off again. So we have 12 plus 2 plus 16 equals 30 grams per mole. And using dimensional analysis, we're going to figure out what is the total amount that we have to multiply this number by to equal this. So how we're going to do this is we have 180 grams per mole, and we're going to divide this number by the 30 grams per mole that we have. If you notice, the units will cancel out, and your ending number would be 6. So what we're going to do is we're going to grab this 6, and we're going to multiply it times the CH2O. So we're going to end up with C6H12O6, which is glucose.